Hi everyone, it's Ian here from Crack Maths and welcome to tutorial 70 on how to make estimates using a scatter graph. So for this tutorial, what we're going to be doing is we're going to be looking at scatter graphs that usually have either a positive or negative correlation, and we're going to be putting on lines of best fit and using these lines of best fit in order to make estimates about other results that we don't have or that we do have. So let's have a look at this scatter graph that I've got here. So I've used this scatter graph before. This is a scatter graph that shows the relationship between traffic collisions and temperature. So just as a quick recap of tutorial 69, we can see that the relationship between recorded traffic collisions and temperature is a negative correlation, which means that when one of them goes down, the other goes up, and when the other goes up, the other goes down. And what we've got here is we can see that on this graph, there has been a line drawn through the data, okay? Now, it's worth noting that this line, which we call the line of best fit, only goes through the data that we've been given, okay? Because we can't actually talk about any of the data outside of that range. So although we can see that there is a negative correlation between recorded traffic collisions and temperature, we can only say that that relationship exists between the temperatures of 0 degrees and 23 degrees. Because it could be the case that after 23 degrees, the recorded traffic collisions do something else. I mean, I would imagine, actually, if the temperature went up to, say, 50 degrees, there'd probably be loads of recorded traffic collisions because all of a sudden it's unbearably hot. The sun might be really strong. It might cause things to blow up. As the temperature definitely gets higher, that correlation is not going to stay the same. So remember, when we make estimates from a scatter graph, we can only do this for the data that we have. Right, so I've drawn the line of best fit through the data points, and we can see that it loosely aligns with all of the points that we've got there, but it isn't exact. You should never try to force your line through too many points. You need to just make sure that it's giving you the kind of the pattern of the data, but isn't strictly trying to adhere to the points that you've plotted. If it's a positive correlation, you need to avoid the urge to make it go through zero. We'll go for a positive correlation one soon so that you can see what that looks like. So, making estimates from a scatter graph. Now, the reason why this is called making estimates is because we're going to take data about, in this case, traffic collisions and temperature from our line of best fit, and we're going to ignore the actual points. So everything that we now do is an estimate because it's only linked to the line of best fit. So let's have a look here. Say, for example, I wanted to know how many traffic collisions happen when it's 10 degrees. So in order to do that, what I'd do is I'd look for 10 degrees here, and then I'd draw a line up to the line. And then when I hit the line, I'm now going to read across to the number of recorded collisions. So if I look here, that looks to me like 30, let's say that looks like 37 collisions, okay? So if I was asked from my line of best fit to estimate the number of collisions on a day when it was 10 degrees, I would say 37. If you need more help reading from graphs, there is a tutorial available to you. It's tutorial 59, which is how to identify the scale of a graph. Otherwise, keep with me and let's look at some examples. So here we go, we've got another example here, and this time we've got a graph which shows the number of visits to the GP, plotted against age in years. We can see here that the graph has a positive correlation, which means that as people's age increases, their number of visits to the GP also increases. And we can also see that there is a line of best fit that has been plotted, and you can see here that it hasn't been forced through 0, 0. So that is good. I mean, sometimes there might be a case where it would naturally go through 0, 0, but usually it doesn't. Okay, and if you do force your line of best fit through 0, 0, then you will get marked down for that. Here we go, we've got our line of best fit. We can see this is a positive correlation because they're increasing together. So now let's have a look at if we can ask some questions from it. So I'm going to ask you quickly, If somebody is 5 years old, how many times would you have expected them to visit the GP? Okay, so have a look. So I'm going to read up here from 5. I'm going to hit the graph, and now I'm going to read across. I can see on this scale it's going up in 5s on the side. So one of these little squares represents 1, so that's nice and easy. So I would say that somebody who's 5, I would expect to visit the GP 7 times. Okay, let's have a look at another one. How many times would you have expected somebody who was 20 to have visited the GP? So here we go. I'm going to read up the 20 line. Now, you might notice that there is a point actually plotted on the 20 line. But we need to ignore that because once we've drawn our line of best fit, it's like the points no longer exist, okay? The points are gone. So we read up from 20, and then we're going to read across here, and that looks to me to be just over 20, but it's not yet 21. I'm going to just say that that is 20. So with these questions, they always give you a little bit of leniency. So I'm going to say that the person that is 20 has visited the GP 20 times. Okay, let's have a go reading it the other way. So how old would you expect somebody to be if they'd been to the GP 15 times? So I'm going to go here to GP 15. I'm going to read over until I get to my line of best fit. And now I'm going to read down. And to me, that looks like they would be 14 years old. Now, the only other thing that happens with these questions is you might get asked to calculate a difference. So, for example, you might say, how many more times has somebody visited the GP when they're 20 than when they're 15? Okay, so in order to do that, what we do is we need to find our GP visits for 20, we need to find our GP visits for 15, and then we need to work out how many more times the person that is 20 has visited the GP than the person that is 15. So we know that the person that's 20 has visited 20 times. Let's look here for 15. We can read up at 15 and see that the person that's 15 has visited, let's call that 16 times. So therefore, we're looking at the difference between 20 and 16. 20 take away 16 is 4. So we'd expect the person that is 20 to have been to the GP 4 more times. Okay, well, there's not much more to this. So if you want to go back through that example that I've just done, do that. Otherwise, there's plenty of questions here over at crackmaths.co.uk, both in the practice and the scenario section. Make sure you have a go, and I will see you in another tutorial. Well, this is the last tutorial actually, so if you've made it to here, excellent work. A good thing for you to do now would be to have a go at some of the past papers. So well done, and good luck in your exam. Bye.